So in this video, we're going to talk about how to use the difference of squares to factor polynomials. So let's look at what happens when you multiply something like x plus 6 times x minus 6. So here I used FOIL to multiply these two binomials. So first times first gave me x squared. Outside, x times negative 6 gave me negative 6x. Inside, 6 times x gave me 6x. And then the last, 6 times negative 6 gave me negative 36. Remember, then I need to add up all my terms. So when I add all my terms together, notice that the minus 6x and plus 6x are like terms that I must combine. When I combine them, they're going to form 0. So that basically middle part is going to cancel out of my expression. So my final answer is x squared minus 36. So this is where we get that difference of squares factoring pattern. So if you're multiplying the sum of two terms times the difference of two terms, that's going to equal the square of the first term minus the square of the second term. So x plus 6 times x minus 6 is x squared minus 36. Okay, a plus b times a minus b is a squared minus b squared. So to use the difference of squares, you need to find the square root of a variable term. Okay, so I just want to quickly go over how to do that. So when you take the square root of a monomial that has a coefficient and a variable, remember that we work with coefficients separately from the variables. So the coefficient, you just take the square root like you normally would. Okay, so whatever that number is, just take the square root of it. Then the variable term, you're going to look at the exponent and multiply the power of the exponent by 1/2. Because finding the square root is the same thing as raising something to the 1/2 power. So let's look at what this means. So suppose we want to find the square root of y to the 6th. Okay, so we can rewrite that as y to the 6th to the 1/2 power. Okay, so now we're taking the power of a power. Well, remember we have that exponent rule that a to the m to the n equals a to the m times n, right? When we're doing a power of a power, we multiply the exponents. So I'm going to do 6 times 1/2, and so that's going to give me y to the 3rd. Okay, so the square root of y to the 6th is y to the 3rd. Well, what if I want to find the square root of 36x to the 24th? Well, I'm going to rewrite this as the square root of 36 times x to the 24th to the 1/2. Okay, the square root of 36 is 6, and then x to the 24th to the 1/2, well, we just multiply 24 times 1/2, and that gives us x to the 12th. Okay, so 6x to the 12th is the square root of 36x to the 24th. So just in case you need a quick refresher, there is that study guide with the chart of perfect squares. And you can use this to help you identify perfect squares and expressions you're trying to factor. So if you see any of these numbers that are written here, it kind of gives you a clue that maybe you should be looking at using the difference of squares. So here are our steps. Remember, always in factoring problems, we're going to start off by factoring out the GCF if there is one. Then you'll check to see whether the first and last terms are perfect squares. Then you take the square root of the first term and the square root of the last term, and we'll write the two factors, the sum and difference of the square root of the terms. So let's try this example. Let's factor x squared minus 144. So notice that these are both perfect squares. So I'm going to take the square root of each term. So like the square root of x squared is x, right? Because half of 2 is 1, and x to the 1 we can just write as x. So this is like x squared, okay? And then minus the square root of 144 is 12. So we have x squared minus 12 squared. So we can use the difference of squares to factor. So this is going to be x plus 12 times x minus 12. So I know as you get more experienced with this, some of you may not need to write out this middle step. And that's perfectly fine if you don't need that, okay? If you can just go straight from x squared minus 144 to x plus 12 times x minus 12, that's fine with me. All right, so let's try this example. So we have 4x squared, okay? Well, the square root of 4 is 2, and then x squared to the 1/2 power, well, 2 times 1/2 is 1, so that's just going to be x to the 1, right? So that's just going to be 2x, so 2x squared minus, and then the square root of 81 is 9, okay? So that's 9 squared. So we can write this using the difference of squares as 2x plus 9 times 2x minus 9. All right, now you can go ahead and pause the video and try doing this example on your own. So notice here we have two terms that are perfect squares. So the square root of 25 is 5, and then y squared to the 1/2 just gives me y. The square root of 36 is 6, so we have 5y squared minus 6 squared, and we can write it using the difference of squares as 5y plus 6 times 5y minus 6. So now let's try factoring this expression. So we have now two variable terms, but you see we have even exponents on both, okay? And then also our coefficients are perfect squares, so we know that we can use the difference of squares to factor. The square root of 49 is 7, and then x to the 4th to the half, well, half of 4 is 2, so we have 7x squared, right? Minus the square root of 25 is 5, and then half of 2 is 1, so that's just going to be y, and then that's squared. Okay, so we can write this as 7x squared plus 5y times 7x squared minus 5y. So now you can go ahead and pause the video and try doing this example on your own. So once again, you see we have even exponents, so that gives us a clue that these are perfect squares. 9 and 16 are also perfect squares because they're on our chart. So the square root of 9 is 3, half of 4 is 2, so we have 3x squared. And then the square root of 16 is 4, and then half of 2 is 1, so we have 4y squared. So when you write it as the difference of squares, we have 3x squared plus 4y times 3x squared minus 4y. So if an expression contains two perfect squares that are being subtracted, you can use the difference of squares to factor. The factors represent the sum of the square roots of the terms and the difference of the square roots.